get it wrong is they rotate from the horizontal axis. I repeat again, a lot of times students get it wrong is they rotate from where? The horizontal axis. Wrong. You rotate from point what? Point Y. Are we clear? Okay, I've been teaching this since 2008. Every year the mistake is the same. It's either the instructor is crap or the student is not listening. Sometimes the instructor is crap, okay? Yes. Oh yeah, the instructor is crap. You, that's true. You can sketch. You have to label your points properly. Okay. So point Y to Y25 is 50 degrees clockwise rotation. Okay, you have to be clear that's clockwise. Why did we rotate 50 degrees? Because on Mohr circle is 2 theta p, on the element is theta p. Taram prick. Are you okay? Remember, I told you guys, right? This was over here, right? This was the theory, right? Right. I described this in. Is it quite a while ago? No, maybe it's page 4. Oh no, page 3. Right? On the element, it is theta. On Mohr circle is 2 theta p. Okay? Or 2 theta. Right. So now we are going to determine this. We are going to determine what is our stress Y25 and shear Y25. We are going to determine what is our normal X25 and our shear X25. Okay, we're going to determine that now. So before we determine that, we need to find our angle over here. I update and then it crashes so often, you know. So this is our stress X25, our shear X25. Okay. So now we want to determine our angle over here. This angle is known as our beta angle. So it's easy to determine the beta angle. 2 theta p, we determined before it was what? It was 21.8. Okay, so this is 21.8. Okay, so we know that beta is equal to 50 minus by 21.8 is equal to 50 is equal to 28.2 degrees. Okay. So we also know our radius of circle which correspond to our tau max. And this we found out is equal to what? 80.777. Okay. So my advice for you is find the shear first. I repeat again, look for the shear value first. Okay. So we know that shear Y25 is equal to your shear X25, and this is equal to sine 80.777 sine by 28.2 degrees. Okay. So this will be equal to 80.777 times by sine 28.2 is equal to 38.17 degrees or 171 or megapascal. Okay. So why did we do that? Okay. So if I were to draw the center of the circle, this is our point O. our point O is at 15 normal stress, 0 shear stress, right? And then we managed to find that this angle over here is 28.2 degrees. Okay, so this is our from the horizontal, this is our 28.2 degrees. We know the radius of the circle is equal to 80.777, right? So now we know that this is a right angle triangle. Right? So this value or this location over here, right? The shear Y25 is equal to 80.777 sine 28.2. Are we clear? Right? That's how we get it. So what I've done down here, right, is I have this triangle over here. I've drawn it over here. Are we clear? Okay. Right? This triangle and this triangle are the same triangle. Okay. Yeah. Right. So from here, we can also find our normal stress Y25. Now, normal stress Y25, we have to include the what? The 15, right? Because the center of the circle, the coordinate is 15 and what? 0. 0 on the y-axis, 15 on the x-axis. So it's 15 plus. Now, this is why I do the shear first. The next form is going to be 80.777. On the shear, we use sine. On the normal stress, we use what? Cosine. Can you see it? It cannot be the same sign, yes or no? It has to switch. Why? Because this is equal to 80.777 cos what? 28.2. The distance from here to here. Then you have to add the what? 15 plus. That's why I always do the what? Shear first. Okay. Why I always advise this, because I've been doing this too many times, and where I make mistake. So I realize if I do the shear first, and when I do the normal stress, I will not make the same mistake. Are we clear? Listen from me, okay? I think I have the right to say that I eat salt more than you eat potatoes. Or in Chinese saying, I eat salt more than you eat rice. Okay, so salt is very small, rice is big, right? So to eat something more when it's small, you need to eat a lot of times. Okay. So from here, this is equal to 15 or 15 plus by cos 28.2 times by 80.777 is equal to 71.189. So it's 15 plus by 71.189 is equal to 86.189 megapascal. Okay. So from here, you can calculate your stress X25 is going to be 15 minus 80.777 sine cos the same 28.2. So this is equal to 15 minus 71.189. Why is it minus now? Because X25 is going to move towards the what? the left-hand side. That's why you do the minus. Okay, so 15 minus by 71.189 is equal to minus 56.189 megapascal. Okay. So these are your answers, but this is not enough. Now we have to bring it back to the element. Okay, now we have to bring it back to the element. And again, it is not difficult. Okay, the technique I'm going to teach you is not difficult at all. Okay, I'll wait for you guys to finish copying first.
I don't understand why.
Why what? Because it's on the right-hand side. This is 15. This point over here is on the what? Right-hand side. Yes? You plus. X25 is over here. Right? So it's going to be on the left-hand side. You minus. This is a stress average. Center of the circle. Okay? There's no initial. Center of the circle. Don't give me new terms, you cheeky sort. Center of the circle.
No, but you know how there's like the neutral axis?
That is zero line.
Right.
Yeah.
And then there's the 115,0.
That is your stress average line.
So
That's the center of your circle.
Right. So adding that 15 to the stress Y25 and stress X25.
Yeah, because that is the center of the circle. Right? Everything is relative to the center of the circle with your stress average. Because the zero means nothing. The rotation is not from here. Right? The rotation is from where? The minus 15, the plus 15. Right? Okay. Right. So now we are going to take this information and bring it back to the element. So go, oh man. Okay. And it's not difficult. Okay. Now we are going to bring this information back to the element. Okay. So we are now going to construct the element again. Okay. So this is our original. Right. This is our original. Then we are going to rotate clockwise 50 degrees. So we're going to rotate this clockwise 50 degrees. Okay. So this is our X and Y. Now we rotate this clockwise. Sorry, 25, not 50. What am I doing on the 25 degrees, not 50. I do apologize. Okay, 25 degrees. Okay, so this is our 25 degrees line. Okay, I'm going to copy this and I'm going to paste and then I'm going to rotate by 90 degrees. And this is our 90 degrees, 25 degrees rotation. So we know from here to here, rotate by 25. Okay, likewise, from here to here, rotate by 25. Okay. Then again, like the same like what we've done before, we draw our element. Yeah, we draw our element. Then like before, we call this our Y line, and this is our X line. So we know this point